Hello, my name is Young, and today's webinar will be on a deep dive into automated security as code for Kubernetes. Some housekeeping to keep in mind. Under Handouts, we've added the NeuVector's Kubernetes Security Guide for download. This webinar will be recorded, so a follow-up email with the recording will be sent to you shortly after. If you would like a copy of the presentation, please send us a quick email or request it under the chat box, and we'll send that to you guys. If you have any questions during the webinar, please feel free to address them in the chat box. Q&A will be brought out throughout the presentation. Again, thank you for your attendance, and I'll go ahead and hand this off to our host, Glenn Kosaka, Vice President of Product Management. Glenn, would you like to take it from here and also introduce our main speaker?
Hello, yes, thank you, Young. Excited to be here, and thanks everyone for joining us today. Automation is one of my favorite topics, so I'm very excited for today's webinar. And specifically within automation, the whole topic of infrastructure as code, security as code, to me is one of the most exciting things, because I really think that for the first time, we have the opportunity to automate security policies into the pipeline. So as Young said, feel free to ask questions as we go through this material. We like to keep it as interactive as possible. So I'll be your host today. I'll be watching for any questions, and Tracy loves to take questions during his talk. So please keep it interactive. So with that, I'd like to introduce Tracy Walker, who's a solutions architect for NeuVector. Tracy spends his time working with our customers on many implementations of container security, and also helping them understand their pipeline, how they're trying to automate their entire pipeline, and how to build security into that pipeline, or how to automate it. So with that, let me turn it over to Tracy. Tracy, all yours.
Is this where I pretend that I'm on mute? Hey, everyone.
We can hear you.
Excellent. Excellent.
You're good.
Thanks for attending, everyone. Thank you, Glenn and Young. Very excited about today's presentation. Let's jump right to it. So a quick agenda. We're going to talk about security as code, what it is and why it's important. You'll notice that I've put some times next to these because frankly, the best way to show you appreciation for coming to this webinar and paying attention to what we have to say is for us to say it and move on. Certainly do not want to bore anyone to death or PowerPoint anyone to death today. So we're going to cover what Kubernetes CRD is, why it's really useful when we're talking about security as code. Then we're going to talk about NeuVector's CRD, why network inspection could be the most important security layer that you can implement in a Kubernetes environment. That's a pretty bold statement. And then we'll do a very quick demo showing how we can apply security policies and how those can be used as security as code. And then, of course, hours upon hours of Q&A, because we love the questions. So we'll be here all afternoon. So what is security as code? Well, let's take a step back for a moment and think about infrastructure as code, or security as code for applications running in like typical VMs in the cloud, right? You can define security groups, you can define firewalls, virtual private cloud VPCs, load balancing, lots of other things that you can enforce and secure, and that's kind of helped drive the movement to cloud, because as well as the DevOps movement, we're shifting things left that can be defined early in the development lifecycle, that can then be tested and verified and validated, and it takes some of the load off of the operations folks for not having to define that. It's coming from the people who know what's going on. Well, the same thing with security as code, right? So if we talk a little bit about, specifically anything that can be a declarative configuration or a declarative state that's that you can store in version control can be security as code, right? And the ability of Kubernetes to make reality match that declarative state, that is essentially one of the core concepts of Kubernetes, right? So, and that improves the speed and reliability of deploying your software. So what this should tell you from the outset of this conversation is that security code isn't just one thing. It couldn't be many things. So if you think of security as code as a bit of a unicorn, you're not alone. I'm here to tell you it is not a myth. It's a very real thing. There are challenges within Kubernetes. Well, first, what should be in a declarative configuration? What security settings are we going to set? Second, rapid deployment. So when we talk about Scrum teams and daily stand-ups, two pizza teams, DevOps relationships, when we talk with customers, and I'm painting with a broad stroke here, but generally the security folks are sometimes not as participant as they would like to be. They sometimes get to eat a piece of pizza, but they don't always get to really contribute to the conversation, because in these environments, if you are, you're trying to deliver software. So anything that slows that down potentially even becomes a security risk. And finally, Kubernetes itself, it's basically a flat overlay network. And we really don't have a lot of visibility into the east-west traffic. And if you don't have visibility into your network traffic, that's potentially a problem. If you're attending this, you probably already understand what security as code is, or at least why it's of value. The real answer is, well, if you have to go to management or someone to say, well, why are we going to start doing the security as code thing? The answer is the same reason why you're using containers or orchestrators, right? You're looking for speed of development, agility, reliability. It's the whole reason why we've got CI/CD pipelines in the first place, and DevOps. All of these things are trying to release value for the business. Security is an incredibly important piece of that, but security isn't paying the bills necessarily either, right? It's one of those things that needs to be there, and there's probably a lot of opportunities to implement security as code immediately. And one of those is certainly our implementation of how we can set security policies automatically in your CI/CD pipeline. So everything I'm going to show you in about the next 20-25 minutes, you can do this in minutes. Deploying NeuVector on average takes between 20 and 30 minutes. Like many things in Kubernetes and with containers and Docker, very easy to deploy. We have Helm files, very, very, very easy to do. And finally, a bold statement: security policies that are based on application behavior, which usually, if you're looking at fine-tuning those, and expressed as a declarative configuration, this could be the most important layer you use to protect Kubernetes. And I'll justify this bold statement here in just a moment. So moving to, let's just review for a moment what a Kubernetes CRD is. So the Kubernetes API, it's structured all around resources. And those resources that we are used to dealing with, like pods, nodes, containers, services, we can address those using kubectl, the Kubernetes API, etc. So a custom resource definition, or a CRD, is just an extension of the Kubernetes API, and it allows us to define our own resources, our own API objects, and define our own kind, like a pod or a deployment or a replica set. So what this means is that you can extend Kubernetes to manage and automate the desired state of your custom resource. For example, I recently watched a conference talk given by some folks from Pivotal, and they were demonstrating how they could use a Kubernetes CRD to manage the lights on in their house. So that if they declared that a light was on, Kubernetes would automatically manage that light was turned on or off. And it was nice and cute until you really started to think of the implications of being able to customize Kubernetes that way. For example, all of the street lights in your city, or all of the traffic lights in your city, that Kubernetes, by using declarative states in a CRD, that's what Kubernetes is good at. It's managing that state, making that state match what you have in those YAML files. So when it comes to NeuVector, we have defined two types of CRDs that we use. NV security rule, this is scoped at a namespace level, and the cluster security rule CRD is scoped at a cluster level. And we'll spend a little bit of time kind of looking into both of these. Also important to mention, the NeuVector CRDs do support Kubernetes RBAC for using role binding, so you do have security around the CRDs as well.
Hey, Tracy.
Hey, Glenn.
Question came in from Dennis. How do you deal with competing policy objectives from different policy authors with different policy change rhythms and priorities, or even authorities?
Dennis typed different 3 different times. Wow.
Exactly. So a lot of differences, different people, different change rhythms, and different priorities.
Great question, Dennis. Ultimately, in software, you have different people with different responsibilities for your code, right? Developers typically are responsible for changing that code, checking that code in, but usually they're not just making unilateral decisions on what goes into that code. And that's exactly the point of a two-pizza team, that you want to have the interested parties participating, the UI folks, the security folks should be there. So I think what's really important is that there is transparency between those groups of what they're implementing, and communicating those concerns and agreeing to who is actually going to put those policies in, whether they're defined by a security team or whether they're defined by development. As long as everybody's communicating and reviewing those objectives and how they align with the business objectives, I think that's, if I'm managing, and I have managed development teams before, that's how I would approach that. We always had really good relationships with our compliance officers and the security officers, because we would invite them. This is, dating a little bit, but even, no matter what the environment, how unique it is, your SDLC, communication and understanding of what you're trying to achieve is probably would be my answer to that.
Sounds good. Yeah, and you said different 3 times, by the way.
I was trying to match this.
But I like what you said about a couple things. So collaboration, first of all, you have DevOps, security teams, they got to work together. So that's number one. And then you said that, well, you've got a development process that governs how people check out code and check it in, and who's allowed to make what changes. So the same types of processes and restrictions or access control should be applied to security policy the same way it is in development. So thanks for that. Carry on, Tracy.
Thank you, Dennis. Yeah, any other questions, feel free. That's much more fun to keep it interactive. So at a high level, you define a CRD, and the type or the kind that you're going to define that as is going to be a custom resource definition. This is what that looks like. This is essentially the complete CRD for our NeuVector security rules. And you'll notice there's not a whole lot to it. You're just basically saying this is a custom resource definition. It's called, the kind is NV security rule. You'll notice also the scope is its namespaced, right? So this is compliant with Kubernetes, makes it very easy to define a CRD, and this is going to have a list of stuff in it. So when you then use a YAML file that is of that kind, that says it's an NV security rule, you can apply that to your configuration, and Kubernetes, as Kubernetes does, is going to try to reflect that state in reality. That's what Kubernetes does. And that's really basically how easy it is. Now, at the risk of everyone going to surf for pajamas on Amazon, I'm going to show you a little bit of what that YAML looks like. So This is a very small portion of a security policy written in YAML. And why is this important in the scope of security as code? Well, because you can version control this. We can write a security policy around your network policies, your ingress, egress, process and file system activity, which is a lot. And now you can enforce those across different environments. Again, we're integrated with role-based access control. And so this is the kind of the core, this is the piece that you're handing between the different environments that's going to be part of your CI/CD pipeline. Now, if you were to ask a developer to create this, you're probably not going to get a Christmas card this year, because there is nothing in this file that says fast or speedy or, you know, week or 2 week sprints at all. There can be a ton of information in this file. So this kind of brings us to one of the advantages of using NeuVector as the tool to introduce this type of capability into your environment security as code. So big picture, NeuVector has two major components to it. We have a scanning engine, very fast, and we also have a network inspection component. Now this network inspection component, basically I was talking a little bit earlier about that east-west traffic, again, you're not much visibility into that east-west traffic within Kubernetes. As Kubernetes has evolved, you know, we have a lot of perimeter security, you know, firewalls and load balancers around Kubernetes, kind of like the moat around the castle. But once you get into the castle, not a lot of visibility there. What's the communication that's happening? And typically, and I know one of the questions that we got before the seminar was asking us if we would point out differences between us and some of our competitors like Aqua and Twistlock and some of those. We typically don't mention them a whole lot. We live free, rent free in their heads, but this is the big difference between us and basically every other competitor out there, because NeuVector can see that east-west traffic. We actually can see the network traffic, and in fact, this is patented. Our patents are about being able to transparently inspect that network traffic for, you guessed it, port, protocol, processes, and file access. Now you can kind of see how the puzzle pieces are fitting together when we're talking about CRDs and security as code. If we're able to see the traffic and we're able to identify the behavior of your applications running in Kubernetes, then this gives us a significant advantage if we want to stop something from running inside of Kubernetes. In fact, this capability beyond just security as code gives you a lot of other capabilities, especially around zero-day protection, unknown CVEs, which who knows? Are the majorities of CVEs been found or not? Do we know? I don't think we really know that. As well as automating a lot of this type of information. The other thing that I want to point out really quickly, and we get back over here to when we were talking about these different rules here that's in the YAML file. Again, we got the type, the NV security rule. We're talking about the egress, the ingress, the port protocol, the ports, file access, process. You notice down here at the very bottom, this policy mode, and this one is set to monitor. So that's a key to understanding here with NeuVector, that we actually have some policies that we enforce when we're talking about that network traffic. So let's talk really briefly about that. We have 3 different modes. In the discover mode, NeuVector is just looking at the traffic and watching it. And we do this from the onset that you install NeuVector. So when I said it takes about 20, 30 minutes to install NeuVector, at the point that NeuVector is running in your cluster, we are immediately discovering all the traffic that is running inside your cluster. We are not a sidecar. We are not code injection. We run as containers. We run in a privilege mode. We also are a daemon set, so we are deployed with every node that gets deployed. That first node is discover. We're immediately learning everything we can about all the network traffic, the processes, file access, etc. When you switch to monitor mode, as we had in that YAML example, now we're going to alert to any behavior that does not fit what we had seen before. So if you were in discover mode for maybe an hour, 12 hours a day, a week, a month, it doesn't really matter. We're going to learn all the processes, all of the file, all the network communication that's happening. And then in monitor mode, we're going to take that set, and anything that falls outside of that set is going to be blocklisted, or at least we're going to alert you to it. When we go to protect mode, now we're actually going to prevent that behavior from happening. And so this really comes in handy, especially in environments where we've had customers come back and tell us that we've actually prevented accidental outages because we prevented an administrator who didn't realize they were in the wrong cluster when they were, trying to take down an environment, and we prevented that process from actually executing within that environment. And you can do this at a very granular level. So it gives you a lot of flexibility about how you want to look at, say, your security drift between environments. Okay. So after covering that, I think that our next step, oh my gosh,
Well,
it
a
is
couple
time.
questions.
Yes, please.
All right, so let's see. How would we do this for security rules that are not for applications? You talked about learn the applications, like general prevention of SSH, SCP, or internet access.
Exactly the same. So we, and I can show in our example here. So let's get logged in. When we look at, so as we come into NeuVector here, the first thing I like to show is just this network activity. Oh, I may have timed out. We'll see if this.
Yeah, one thing I'll throw in there while you're logging back in is that NeuVector is learning and whitelisting all of the allowed behaviors. So it's a kind of a whitelist declarative policy. So by default, all connections to the internet would be blocked if they weren't part of the initial discovery process. So
Exactly.
but I think you're going to show us how you can create those rules if you'd like to.
Absolutely. Let's take an example. I'll pick this one right here. So you can see when I pick this group, a couple of things. So we have rules, network rules here that are learned. So that's part of that discover mode. And also when I come here, we'll see these process profile rules. And you notice that, so something that has been learned here and is allowed is someone ran a find command, a pause command, as well as this Redis server. So we've learned those. So if someone happened to secure shell into a container when you were in discover mode and did an LS, did a CP, we're going to learn those behaviors, and we're going to basically allow those behaviors if you just promote that. But the real point of this is being able to review what was learned. And in fact, I'm going to show here in just a moment. Let's take, were there other questions, Glenn, before I?
Well, I think a related question, which you're just touching on, and you can continue, is what about anomalies during discover mode? So
Yes.
I think you're about to talk about
that. And
that.
that actually is a great question because, even, yes, if you do something in discover mode, you are now basically creating a rule automatically that this is something that happened in the environment. So you're going to want to review that. Let's show you an easy way to do that. So I'm going to pick a couple of groups here, and I'm going to do this. Actually, I do this every time. This just changed. It's now all in one place, but for the sake of the demo, we'll just do it right here. We've just moved some buttons around in our latest release. So you see, I'm going to export my group policy. So I can pick multiple groups. This can be an entire environment. This can be an entire, an application, etc. I don't have to pick everything. I'm going to export this, and it's going to come up. We'll just call this, we'll call it Tracy YAML. Doesn't matter what it's called. I'm going to save that. So inside that file, Here we go. So exactly what we were just looking at, we've got a NeuVector security rule. So our scope is going to be namespace. And then we've got all of these different rules. And so, so again, now you could do a diff. If you had two different environments and you're like, well, I want to see the difference between these two, you could certainly do a diff between those and see and kind of go through all of the YAML. That might not be as much fun. An easier way to do this, let's go to, and let me point out before I do this, in NeuVector, in this particular environment, we have 3 different Kubernetes clusters. I have one running on GKE and Google. This IKS is running on IBM Cloud, and my NVSE demo here, that's running in Amazon, AWS, Elastic Kubernetes, EKS. So you notice here, so I've got some groups here. This is a very similar environment, just like you would have in your, your QA, UAT, staging, prod, exactly. They're going to be kind of similar, but they're also going to be a little bit different because you are going to run some QA rules and things like that. You'll notice here that my entire environment is in discover mode. So if I were to log into, secure shell into one of these containers and run a command, we're going to learn those commands. In fact, this one, I think will have, you'll notice that on this Redis pod, which is what I selected earlier, we've got a couple of extra. There's a bin ID, there's a 5 here. I wonder how this would compare against the GKE demo or environment that I was looking at. So let's go to, we're going to be in this environment. So there's my YAML file. I'm going to apply, let's do this. And I'm going to apply that using kubectl. This is already pointed at my AWS environment. And you'll notice that I have these NeuVector security rules have been applied to this environment. So let's go back to our environment, and I'm going to refresh my screen. And you'll notice that we have some different colors showing up. These CRD, right? We filtered back down to my demo pods, and you notice now I have CRD for these rules. You'll also remember that I had it set to monitor. My Google environment, I had everything set to monitor. So when I exported that CRD YAML and applied it to this environment, it set using NeuVector this environment to monitor mode. So I can control the policies. I can also control the monitor mode that's being applied. Let's look at that Redis pod, the network rules here. These match. So we've got 2 different rules. One was learned, one's a CRD, and these match, and that's a good thing. But I notice up here, I've got, for my Nginx, I've got some differences. I have a DNS learned rule that was run in one environment that wasn't. So this becomes a discussion point between QA and development, or security and development. You can actually start to look at what are all the differences between these environments. Do we need to remove this rule or not? Let's go to this node pod. We've got 4 network rules here that are in the CRD. We've got several that are in the learned mode, and this allows, so we can kind of sort these by different things. Actually, I can't, sorry about that. We've got this one that's different, and that is this SSL connection that is showing up as part of the CRD, but is not part of my learned rules. So that connection right there was being allowed in this environment. So you know what? I want to change that. We've had a discussion. We're going to go to and I think if I just search for Google, and how many places do we have Google in here? Oh, that's it. This is the only place we have Google. And notice down here, this action is set to allow, right? I don't want that. I want that to be deny. And now I'm going to apply that YAML file again. And you notice that most of these are unchanged, but this one right here for this particular pod has been changed. So when I go back here and I do a refresh, Now we are denying that. We have decided that we are not going to allow that SSL connection to google.com, and now we're denying it, and that's part of the CRD. You'll also notice I can't select these and make changes to them. So this is also part of that RBAC, that I had the ability to apply it, but when we're using a CRD, that overrides anything else in the environment. So I can still add network rules, I can still add different things that can be learned. Well, I take that back. I can't learn anymore because I'm in monitor mode. So if we're in monitor mode, we're going to alert to say no, or to alert to anything that's anomalous to the application behavior. In protection mode, we're going to say no, and we're going to stop it. Also notice I can't change that mode. So this actually does add some additional security, that now we're going to manage these security policies using the CRD, and that's what we want enforced in those environments.
Want to take a few questions?
Please.
Okay. Start with an easy one. How long should I run in Discover mode?
How long does it take you to exercise your application to your satisfaction? Again, in a learning mode, if you're in a QA environment and you're running a lot of automated tests, you're probably going to see a lot of rules related to those. So you're going to want to do a little bit of comparison between upper and lower environments. And we've seen lots of different approaches to this. We've seen where someone will start their Discover mode in production, and they'll discover everything that's happening in production. Then they'll set it to monitor mode, which is very safe because it's not going to block anything except known attacks that we have defined. So if we actually saw a DDoS attack or a SQL injection or something like that, we're going to stop that anyway, regardless of the mode that it's in. But so there's different ways of kind of your strategy of learning the behavior for different environments and comparing those. We've seen them defined in development and passed up into production to see how they compare. You can start in production and just apply everything there. So, so to answer the short answer, however long it takes to exercise your application to get the information so that you can have a conversation with your development, your operations team, your security folks to say, these are the rules that we want in place. We don't recognize what this is. We want to watch that and maybe even block it or deny it in protection mode.
Thanks, and I think you touched on this a little bit, but maybe summarize it. Can I change the rules in the GUI even in Discover mode?
You can in Discover mode. Excellent question. So if I look at the network rules here, this is very simple. I can add to those. So you'll notice that we do have some user created rules. I can add network rules. I can also look at rules and change them or delete them. A handy way of doing that is just looking at the network topology. This is a live picture. Big difference in the way that we do this is we're not using IP tables, syscall filtering, all the things that all of our so-called competitors are using to identify network traffic. We're actually looking at the network traffic at layer 3, layer 7. We can see the ports, the protocols, etc. When I see a red line here, now this one may be, this is a denied there. You notice I can clear rules out of that. Some of these blue lines, just pick one, it's easy. I've got a whole bunch of allowed learned rules here, and we can clear those. I can actually pick one and review that rule. And you notice here I can deploy it. So instead of it being a learned rule, I can change what that rule is, make it a deny, and actually deploy that right there. So I don't have to type in a bunch of stuff. We've collected all of the detailed information for you so that you can make decisions and then apply very quickly with that action.
Yeah, so just to clarify that, rules are completely configurable through the console or REST API, but I think Tracy touched on it. If there is a rule created by a CRD, and that includes setting whether it's monitor or protect mode for the service, those cannot be changed in the console after that. They must be changed through a CRD change, which is the whole idea behind the policy as code.
Exactly. Great clarification.
Let's see, another question. Any change history available to see what changes happened recently? I assume that means like administrative, like rule changes or additions or things like that.
Well, when it comes to your CRD, obviously, if you are using version control to manage that, that's really going to be the source for your CRD for managing how those changes are happening. So no different than source code.
Right, and then of course, you know, the application of the CRD and the changes made are going to be reflected in the NeuVector event log, the notifications and things like that.
Yes.
And another question, kind of back on one of your previous slides, what kind of encryption logic is applied when it passes data through the internet in your east-west example? What kind of encryption logic?
Encryption logic. I'm not positive I understand that. If the question is, so something like a service mesh, Istio that provides encryption within your cluster, we're completely compatible with that. So we actually can see the traffic before it gets encrypted because of where we sit next to the Linux switch. So we are completely compatible with that. If you're using something like if you're terminating encryption within your cluster, what is it, SNI, I think, or HTTP, if you're terminating a HTTPS within the cluster, we're not going to be able to see that traffic coming north-south into your cluster. But once it's decrypted, even if you're using a service mesh inside, we're still going to be able to see that network traffic and report on it and set policies and things like that on it. In fact, often we have customers who come to us looking to protect their service mesh. So we help harden and protect your service mesh as well.
Mm-hmm. Yep.
Did I miss anything, Glenn?
Nope, that sounds good. And another question, how about connectors to other monitoring tools like Splunk or Elk, Grafana?
Absolutely.
Yeah, I think this was relating to like, you know, the events and the notifications. Yeah.
Yes. Yes, absolutely. The answer is yes.
Yes. What do we have? We have a Prometheus exporter available on GitHub. Typically, people use our syslog interface or webhooks for Splunk interfaces. Okay, that's all for now, Tracy.
Excellent. That did bring up a little bit of that one question about how do we change this and things like that. So as you know, you might imagine, but you may not be completely aware, but you know, so once we apply those CRDs, again, I can't make changes to those. However, they're just as easy to clean up. So if I use my kubectl command again, and I delete that CRD, and I refresh my screen, and let's filter back, and you'll notice the CRDs are now gone. So you can unapply them, you can apply them, makes it very, very easy to change and kind of manage that. And really that does become the kind of the crux of your software as code, is using that YAML file to define those policies.
Can these CRDs be applied by Helm, or you know, what is the best way? Obviously, like you're showing here, kubectl is a way to do it, or you can script it, but this question is also Helm as well.
Correct me if I'm wrong, Glenn. Kubernetes supports the CRDs, so we do have a Helm deployment for NeuVector. So I would see no reason why you couldn't do it with Helm. I have not done that myself.
Yeah, from my experience, it definitely can be done through Helm. You got to be a little careful, I believe. I believe we had one customer who was, trying to apply like a dozen at the same time. So when you're processing those rules, you've got to pay attention to the sequencing. I don't believe Helm offers the capability to sequentially do it and wait for a success indicator back before it tries the next one. So you do have to be a little careful if you're pushing in CRDs that could potentially refer to previous groups created or rules or overlap or conflict. So that's the only thing I would caution about for Helm. Is there an API available for this NeuVector tool?
Yes, we have an API first driven development approach. We develop our APIs before we actually develop the code. So unequivocal, yes.
All right, and Istio policy is established at an application or service level, but you are showing behaviors that can be much lower level too. How do you reconcile association of low level flows with high level inter-application interactions can you do?
Was that for me?
I think the
great question. What a
gist of the question
question
is there can be some overlap because what we tell our customers is definitely turn on encryption, pod-to-pod encryption, because that's easy to do and it's going to dramatically improve the security if you can bear the overhead of encryption as well as all the sidecars running and all the network traffic it creates. But as some of you know, you can do some service layer authentication with Istio. That tends to be fairly complex to set up and manage. But you can do it, and it is complementary to the kind of the network layer 7 segmentation that you can do in NeuVector. I think the main difference is in NeuVector, as Tracy showed, we're going to learn all that and we're going to automatically create that. You just review it and push it into production. Whereas in Istio, you're going to have to create those individually. You don't really have any alerting if any connections were blocked. If your services are attempted to be hacked, there's no packet capture and things like that. So it's a lot bigger challenge to manage all of those policies if you want to do some authentication in Istio.
And I did just bring up, just from a visual standpoint, you can see here we've got Istio running in our IBM cloud environment. These little loopbacks that you see here, that's the sidecar traffic that we're seeing. So that's how that identifies that. And you can see here we've got all of the little circles around the squares. Those are all protected by a service mesh.
Right, so we can not only inspect the traffic going between the sidecar and the workload running in the pod, but we can also monitor all the system traffic between the sidecar and the control plane and all the additional noise that the service mesh puts on the infrastructure.
Any other questions?
Not right now.
Well, we're just about to wrap up. So if you have any questions, I think I've got really just one more slide to talk about. So I made a very bold statement earlier that is network inspection the most important security layer? Frankly, if you're not running NeuVector, you may be missing out on the most important security layer. Again, we are an accurate source of truth. We're our own source of truth for all of your east-west network connections within Kubernetes. Again, we're doing that by looking, if you want to look at our patents, the name of the patent is Transparent Network Inspection. We're able to see it transparently, zero overhead in Discover mode, zero overhead in Monitor mode. Only in Protect mode do we incur a little bit of cost because actually we are in line at that point where we can block processes and network traffic. So that layer 7 segmentation, if you think you're segmenting, take it from Gartner. Gartner says this is one area where almost every security platform is not doing a very good job, with the single exception of NeuVector. And I'm sure you can kind of read all of these different things, the detection of different types of attacks. The big one for why is network inspection the most important really evolves around CVEs, and really kind of the strategic view of a lot of security platforms that they're using CVEs to do image scanning. Now, the analogy that I like to use for this, every car has a rear view mirror. You would feel a little weird if you got into a car and the rear view mirror was missing. It's not really safe, right? But you're not using it all the time. You're using it to check traffic. You use it to back up. You need it there. You absolutely should need it there. And they're not going to sell you a car if you don't have it there. But it's not traffic inspection. It's not where you got your eyes on the road. And so that monitor mode, that protection mode, that's looking at the traffic real time. So even if, for example, if you didn't have any CVEs identified, you're still getting protected, because we're basing that protection on the DNA behavior of your application, the exact network protocols, et cetera. So we can laser cut those security policies based on that traffic. We're not just using something that someone discovered 3 months ago and may or may not have written a patch for. Anytime we do demos, sometimes we'll show, we like to patch everything to almost, literally the latest version of everything. And then we show all the CVEs that have not been resolved in those environments. And it starts to kind of make it, well, we kind of need something for those things other than CVEs. So that's my analogy, why this network inspection may be the most important security layer in your Kubernetes deployment. Not to mention
that answers, I think, the question that just came in. How are we different from other companies, other vendors out there like Twistlock or Aqua? It's really the network part. I would also add to that, we're purely cloud native solution, as Tracy mentioned. We're a container, and we integrate with Kubernetes very tightly. So things like admission controls and security as code with CRDs, RBACs, everything, you manage NeuVector, whether it's deployment, updates, or pushing policy. It's all, how you do it in Kubernetes. So that's another big difference.
It's a huge difference.
So another question, when you release security as code, does it take care of auto scaling?
If I understand kind of where somebody may be coming from, we scale because we run as containers. We scale as you scale. We have enforcers on every worker node, and because we're as a daemon set, and so every time you add a node, we are deployed first, and so we're present in those. So we scale with your applications.
Yeah, and when you scale let's say you have an application, it gets really busy. Your microservice is going to scale up from 1 pod to 30 pods, handling all the traffic to that application. We can scale as well because we're really layer 7 based. We're not based on containers or
exactly pods. And that's why you see, like, for some of these, you'll see how many members they have. So all of these groups are automatically created when we're learning about the environment. And so you see that these groups have different members. So those members may, if you scale up, that the members may increase significantly, but they're all running the same service, or they're all part of that same service. So again, that's basically making this effortless as far as managing your security as you scale up and down and busy and different things.
Yep. Let's see, another question. How does this work with existing Kubernetes network policies? Do we need to rewrite those to a CRD?
That's a great question. I probably will lean on you a little bit for the answer on this, Glenn, because when it
Sure.
comes to conflicting, or you can apply policies in Kubernetes, and then you can certainly apply policies with NeuVector.
Yeah, I would say there's a potential, just like there's a potential for overlap with Service Mesh at layer 7, there's a potential for overlap at layer 3, 4, which is what network policies are based on. So you can create layer 3 and layer 4 policies in NeuVector. So the cleanest way to do it is to convert those to CRDs like Tracy showed, and so that you have them all in one place. And if you do want to view them in the console, you can see all those in the NeuVector console. And that way, not only do you make sure there's no overlap or conflicts, but you get the alerting and monitoring that you don't get with either network policy or service meshes. You know, what connections are happening, packet captures on those, blocked attempts, all of that alerting is going to be captured. Because those tools are not really coming from a security product perspective. A lot of you expect forensics and alerting and captures. So that's what you're not going to really get. Yeah, so feel free. We're kind of at the top of the hour, so unfortunately can't get to all the questions, but we'll answer those and send you answers afterwards. Thank you so much, Tracy. That was an awesome overview and deep dive into security as code and great interaction. So, and thank you everyone for attending. As Young said, we'll be sending out a link to the recorded session. If you'd like to take a look at it or share it, feel free to do that. And there's some downloads in the that you can get. All right. Thanks again, everyone. Have a good day and week. Stay safe, and we'll see you on the next NeuVector session.
Thank you, Tracy.
Everyone.
Thank you, Glenn.